Hello, this is video 1 of section 1.2 in your Algebra 2 textbook. In lesson 1.1, we studied about the equation of a parabola when it is in standard form, how to find the equation of the axis of symmetry, which was done by using this formula, how to use C to graph the y-intercept of the parabola, and how to find the coordinates of the vertex by using this formula and then substituting in the original equation, etc. When the equation of a parabola is in vertex form, as we're studying now in section 1.2, then it is actually very easy to find the equation of the axis of symmetry, because all you have to do is write x equals, and in here you write the opposite of the value for h that is found inside the parentheses. And then to find the vertex, it is also shown in the equation in vertex form. The coordinates of the vertex will be the opposite of the h in the parentheses and the k. K will be the value of the y of the vertex. Just as in the equation of a parabola in standard form, when a is greater than 0, the parabola opens up, and when a is less than 0 or negative, the parabola opens down. Let's do a problem using this information. When you have this equation of a parabola, which is in vertex form. Now it will be very easy to determine the equation of the axis of symmetry, because we said we write in here the opposite of the h inside the parentheses. The h in here corresponds to -1. So the equation of our axis of symmetry in this case will be x equals -1. And the coordinates of the vertex will be the opposite of this h and the -3. Now we can go ahead and graph the parabola. First thing we're going to do is graph the axis of symmetry. Here is the x-axis. The axis of symmetry crosses the x-axis where x equals -1, right there. So I'm going to draw it. So I am graphing the axis of symmetry. Okay. And we're told that the vertex is found at -1, -3. -1, -3. 1, 2, 3. Right here. This is our vertex. And we're also told that a is 2. So a is positive. So this parabola opens upward. We can choose a point, a value for x, a random value for x. Well, not so random. I want it to be either to this side of the axis of symmetry or to the left of the axis of symmetry. If I pick, let's say, 1, what happens when x is 1? That will be my random point. When x is 1, what is its accompanying y? Well, when x is 1, 1 plus 1 is 2, which is going to be 2 squared times 2 minus 3. 2 times 2 is 4, times 2 is 8, 8 minus 3, 5. So my random point is 0.15, which is located here, 1, and then 5 up, 1, 2, 3, 4, 5. So in here we have another point of our parabola, and we can now draw it very carefully. Okay, we're doing here one side of the parabola. If this point is located 2 units to the right of the axis of symmetry, there must be another point 2 units to the left of the axis of symmetry that is also in our parabola. So here we go. And I just drew the parabola. It opens upwards. And that's it for now. If you would wish to rewrite this equation of this parabola from vertex form to standard form, all you would have to do is to multiply to x plus 1 squared times 2 and then subtract 3. And that would give us 2 times x squared plus 2x plus 1 minus 3 equals y, which is 2x squared plus 4x plus 2 minus 3, which is 2x squared plus 4x minus 1. This is the equation of this parabola in standard form. In here, we have it in vertex form. When the equation of a parabola is in standard form, the letter C represents the point where the parabola intercepts the y-axis. So this parabola has a C in -1, and sure enough, look, when we drew our parabola crossed the y-axis, yep, at -1.